Hello, here is my two model assignment video. Um, Start out with the beginning. We were looking at math achievement as our outcome variable. And we set it as our null. We found that this is what the model essentially looks like. We find out that the coefficient is 12.636, so essentially 12.64. And after looking at the variance component, we can see that level 1 comprises most of the group, but 8.61, or roughly almost 20%, consist of our intercept. So roughly 80% is at level 1. And it was significant at a 0.001 p-value. Moving on to adding predictors, we got our model 1, in which we added 3 predictors: minority, female, socioeconomic status, and we based that off of sector as our level 2. As we scroll down, we can see that our intercept was 13.118, or 13.12 essentially, and that number reflects, let's see, those with average male white respondents, and that when we examine sector, we see that the area in which these students go to school is going to increase by 2.303 or 2.30 to add to the score to make it 15.41 at significant p-values. Although when we look at our coefficient 13.7, we find that in general minorities are going to perform less successful in math achievement, so roughly 10.05, and that females are also score less likely to score as well in math achievement compared to males at negative 1.25, and that when we examine socioeconomic status, that those with average socioeconomic status in regard to math achievement are going to increase. So those white males with average socioeconomic status are going to have higher math achievement scores at roughly 15.17, and at all significant. And we see that our variance is still significant. But at this point, we don't know if these are fixed or random. I mean, assuming that they're fixed, but we don't know if this is due to random slopes. And then, moving on. When we looked at math achievement with the 3 predictors, minority, female, and socioeconomic status, with level 2 model as sector as a slope, for minorities, we find that that our intercept coefficient is at 14.152, so essentially 14.15, and that minorities are less likely to have high math achievement scores, but depending on the sector, this could increase their score, ultimately lessening this negative 4.39, and by adding 2.78. So one sector for minorities could actually increase their math achievement scores, but still it would be below those who are white males with average socioeconomic statuses. For females, what we see is still the same, that they score less, and those with average socioeconomic statuses, those with average socioeconomic status are likely to score higher math achievements. And we see that our variance component actually increases here at a significant level. I am unsure why that number increased, but I'm guessing it has to do because we're examining this minority sector, and specifically bisector. But so then we go to my Model 3, in which I ran, and this time what I did is essentially took math achievement, and I just still kept my three predictors of minority, female, and socioeconomic status, but this time I added sector breakdown to each slope. So to slope to sector by minority, sector by female, and sector by socioeconomic status. So I was curious how sector played into those three predictors. And what we found is the coefficient is still 14.15. But here we go. So this is a repeat of last time. So we found that the sector can have a positive impact on the minority's math achievement. Same thing, we found that one sector can also have a significant impact at the 0.05 level for females, as well as a negative impact on those for socioeconomic status. So I'm assuming this last one, the sector, if you come from an area that has poverty, you are more likely to have a lower score than those with the average socioeconomic status compared to a standard white male average socioeconomic status student. So that's how I read that. Hopefully I'm reading everything right and this all makes valid sense. Thank you. If you have any comments or concerns, please let me know. And thank you.